In this demonstration, I'm going to create an EBS volume. EBS stands for Elastic Block Store. You can think of it as being a virtual disk that we can then use with EC2 instances by attaching the volume to it. After which, it shows up as just another mass storage device, as if you had a physical server and had physically plugged in some storage, meaning that you will have to initialize the disk, you'll have to partition it, you'll have to format the partitions just like you normally would. The difference is that it's an object or a resource in the Amazon Web Services cloud. To get started here in the console, I'm going to go to my recently visited and click EC2 to go to the EC2 Management Console. If I were to go to my Instances view, from here I can click on an instance and go all the way down to the Storage tab to check out its storage. For example, here we've got an EBS root device type that contains the operating system, and the root device name is shown here as /dev/SDA1, which is standard Unix and Linux nomenclature for disk devices. So it's shown down under block devices, which is a section I can expand or collapse, with the size of the volume, 30 gigabytes, and the attachment status, of course, is it's attached to the virtual machine that we are looking at the properties of here. I even have an attachment date and timestamp for that. However, in the left-hand navigator, I have an Elastic Block Store section where I can click on Volumes. Any existing EBS volumes will be shown here. And as I scroll over to the right, we've got a volume state column that will tell me whether or not the EBS volume is in use. They're all showing here as being in use. And under the Attached Instances column, we can see the instance ID to which those volumes are attached. But what I'm going to do here is click Create Volume. Now, when you're creating an EBS volume, you can select from General Purpose SSD, whether it's GP2 or GP3. The difference being GP2 does not let you modify the IOPS. You don't get to specify that value, but GP3 does. The IOPS is the input-output operations per second. In other words, a disk throughput measurement, which is very important if disk latency tends to be a problem with a given workload, if there's a lot of read and write activity. I could also go to Provisioned IOPS SSD 1 and 2, depending on what I need for performance, such as a maximum value of IOPS, up to 1,000 IOPS per gigabyte of storage. So we can also specify the size here, of course, in the size field. And depending on what your needs are, you also have magnetic disks or cold hard disk drive storage for infrequently accessed data. The older hard disk magnetic storage technology, HDD hard disk drive, is slower and thus doesn't perform as well for any workloads compared to SSD. But depending on what you're doing to save on costs, perhaps testing and disk I/O is not of the utmost importance, you might select one of these. I'm just going to leave it on General Purpose GP2. Now, I am in the North Virginia US East 1 region as shown in the upper right here, and so I can select the availability zone where I want this volume to be deployed. Under Snapshot ID, I can also choose to create this volume based on an existing volume's snapshot. It's kind of like having a disk image to start from, but I'm not going to create it from a snapshot. I'm going to create an empty new EBS volume. I can also choose to encrypt this volume where I can then select a KMS key, a Key Management Services key. KMS is a cloud-based AWS service where you can generate and manage keys. So I can use the default AWS EBS key for that. And of course, I can add tags down at the bottom up to 50. I'm going to add the name tag. And I'm going to call it Windows Data Vol 1. And down at the bottom right, I'll then click Create Volume. Okay, so it's created our new volume. So if I refresh the view, my Windows Data Vol 1 should show up way down at the list. There it is. So I can click on the link for the volume to open up its details at any time. Here I have the volume ID that was assigned by AWS, the volume state, which is currently available, the KMS key that's used to encrypt it, the size, the amount of IOPS, and the creation date and timestamp, that type of thing. I can also go down under monitoring to check out things like read and write bandwidth, read and write throughput, if I'm really concerned about the performance at the disk I/O subsystem level. But if I go back to the volumes view, I can put a check mark to the left of that EBS volume And under Actions, I can choose to modify some aspects of it, such as the volume type or the size. I can also go back to the Actions menu and create a snapshot of that EBS volume. I'll just call it Snapshot 1. A snapshot is like a point-in-time picture of the current state and data of that volume. And you could use that as a backup source. So I'm just going to go ahead and create the snapshot, which of course, as you might guess, will show up in the snapshots view. So there's Snapshot 1. And I could select the snapshot and go to Actions and even create a volume from it, archive it for long-time storage, delete it. But I'm going to go back to the volumes view yet again. Put a check mark in front of Windows Data Vol 1 and under the Actions button. Here I can choose to delete the volume. I can also choose to attach the volume. And because we decided that we were going to encrypt this volume, there's a message that states it can only be attached to an instance type that supports EBS encryption. But I'm going to go ahead and cancel that. Now bear in mind that when you are in this view, remember that you can check out the volume state column. You can sort by it by clicking on it if you so choose. Now this can be important because if you have numerous available EBS volumes that are not needed, it becomes a cost issue. You are paying for something that's not needed, that exists, that is not being used. So bear in mind you want to watch out then for EBS volume sprawl.